Welcome to the twice monthly Industry 4.0 community podcast hosted by 4.0 Solutions. I am your host, Walker D. Reynolds. Today, we have Mark Pitout, who works for Schneider Electric. He's based in Europe. Today, he's here representing himself, but has gotten permission to talk about Schneider here on the podcast. We've got Zach and Vaughn, who are going to join us here in just a moment. Today, the whole conversation is going to be centered around primarily four topics. Number one, we're going to talk a little bit about Mark and his background and how long he's been at Schneider and what he does. And he's a pre-sales technical consultant. We're going to kind of talk about what that's like. Number two, we're going to talk about Schneider AVEVA leadership, specifically just some changes that have been going on. That is, Schneider's been growing at this huge exponential rate. They gobbled up AVEVA. AVEVA bought OSI Pi. You've got all these big moving parts. And what does the new leadership structure look like? Number three, we're going to talk about OSI Pi specifically. Sort of AVEVA's been taking a lot of feedback from the community on the OSI Pi solution and kind of where do we think that's going to go. We're actually going to talk about some use cases. We're going to talk about Open in OSI Pi, MQTT in OSI Pi. We're going to talk about the asset frame SDK. And then the last conversation we're going to have is just like an architectural discussion about edge-driven versus server-centric. We're going to go over a couple of examples. So with that, we'll go ahead and bring in Vaughn and Zach and Mark. Okay. Zach, Vaughn, welcome, guys. Good to see you. It's funny. I shot a podcast over the weekend that I don't know if we're going to publish it on this channel or, but it's with a guy who does, young guy, actually, super gifted guy who does a lot of machine learning and artificial intelligence. It was a whole conversation centered around artificial intelligence. And multiple times during that podcast, I wish Zach was on there so we could double team this guy. But let me get over the announcements real quick. Hey, for those of you who are watching on YouTube, we never do this, but I'm going to do it now. Please go down and like the video. And if you're not subscribed to the channel, go ahead and subscribe. If you're watching afterwards, subscribe, comment down below. That really helps with the algorithm. I got to do a couple of just quick announcements and then we'll jump right into the podcast. So I'm speaking at IoT Happy Hour this Thursday, June 1st in Richardson here in Dallas. That is at, we'll go ahead and leave the link in the description here. I'm going to be doing a conversation on Industry 4.0 and AI. I'm going to be going over a bunch of use cases. So if you guys are in town, you're over in Richardson, whatever, come on out and say hi. The last time I spoke there was, we had a gazillion people there. It was pretty awesome. Next mastermind call is next week, June 9th. And we're going to have SAP. I think Salvatore is the one who's actually going to be on that call, who's the product owner for SAP digital manufacturing. We're going to talk about integrating ERP. Mentorship call is June 16th. And then we're also going to have Salvatore Castro, who is the product owner for digital manufacturing at SAP. He's going to be on the podcast in our next podcast, June 13th. And for those of you who are doing Advanced MES Bootcamp, our final Advanced MES Bootcamp will be June 17th. We did the ERP integration last Thursday. We integrated work orders and bill of materials into our unified namespace via Odoo. We did it two ways, one through the Postgres backend, and then also through a Python API. And that is June 17th at 8:30 in the morning. All right, with that, Mark Pitout, welcome, brother. Why don't you quickly just introduce yourself? Who are you? Kind of what's your background and what you do at Schneider?
Okay, so I've been an engineer now for close to 20 years. I graduated at the end of 2003 from the University of Johannesburg. Started my career as an electrical engineer, actually, and worked for a consulting engineering firm called WSP. International firm, offices all over the place. But they also happened to be a system integrator for Schneider Electric. After about 9 years of working for them and moving from electrical engineering into control and instrumentation, I then joined Schneider Electric in South Africa in 2013. And I spent the first 4 years of my career there as a projects engineer, doing PLC SCADA type projects.
So on the you were on the services side. You were doing So
Yeah,
actual
executing
solution.
projects, right? Writing, cutting PLC code, building SCADA applications, and then going to site and commissioning it. Took me to places like China, Sierra Leone, Belgium. Took me all over the world, but I was mainly focused on mining, and then later on in that 4-year period in food and bev as well, but on the grain milling side. So it's still all very large continuous process, heavy energy type process stuff that I was automating. And at the end of that 4-year stint, I then felt that site life was not for me. I wanted to be a bit closer to home, so I made the move into pre-sales engineering, and I became an automation consultant. And I did that for 4 years. And then at the end of that 4 years, basically at the end of 8 years at Schneider Electric, 2001, middle of COVID, I emigrated. I came to the Netherlands, and I again joined a system integrator for Schneider Electric. I was there as the Schneider man for Schneider Electric, for that system integrator. But as all SIs, they did everybody, right? They did Siemens, they did ABB, and they were not afraid to look around. But they are an alliance partner for Schneider. Anyway, January this year, I got lured back to Schneider Electric, but now for Schneider Electric Netherlands, and I'm back to my old role, automation consultant in pre-sales, and yeah, that's what I do. So, and the way that I got connected to you is I've been consuming your media for the past 4 years. How long have you been on YouTube? That's how long I've been watching your videos. 5 years. There we go.
2018. Yeah, 2018.
Yeah. I've been my main view of what a unified namespace is via your content.
Okay.
So you made a comment in one of your videos, and that triggered me to lash out in Discord, and so the conversation got started.
So yeah, I'll quickly give the background there. I don't remember which video it was, but in general, this is my. So for those of you who don't know, Schneider Electric is the 4th largest automation company in the world. They're they do 7-8 billion in revenue just on industrial, just in industrial automation. They do 7 or 8 billion annually. Okay, so that makes them the 4th largest globally. Okay. Schneider has offerings from all the way down, if we just talk about industrial automation, all right down to the terminal block inside of a panel, all the way up to the IIoT platform at L3 or L4, and then with connectors directly into any cloud-based solution. So Schneider is full stack. And if you were to look at their offerings today, they actually have a lot of redundant offerings as well. So, Schneider may have, say, Magellan HMI, right? But also AVEVA Edge, which used to be Indusoft. And they basically do the same thing, except one is purely software-based and the other one is hardware-software-based, right? So Schneider has lots and lots and lots of offerings. If you were to look at, everyone knows the Modicon line of PLCs, but when you say Modicon is really like a parent group of PLCs. There is a lot of solutions. You have micro and nano and 850, and Schneider's got a lot of offerings in industrial automation. They are the 4th largest company in the world in this space, and I generally group them into the Rockwell, Schneiders, Emersons of the world. I try to always qualify it, because if you look at the 4 largest, I generally try to qualify that Schneider does some things, in my opinion, much better than the other 3. Okay. In the specific video we're talking about here, I didn't make that qualification. I also make that qualification for Siemens sometimes as well, especially when we're talking about Mendix or MindSphere or WinCCOA. So Mark commented in Discord, and he basically, the nuts and bolts of that comment was, hey, listen, I've been with Schneider for a while. I just recently came back. I just went through my onboarding, and there was nothing in my training that was sell the Schneider stack. It was sell the solution, include whatever Schneider solutions are appropriate, but also you know, design the optimal solution for the client. That's what Mark said. There was a huge conversation in Discord basically saying, you know, Rockwell ought to do this too. And although Mark wasn't speaking, he wanted to make a point. He was speaking on behalf of Mark Pitout and not Schneider. He was still telling us about his insight at Schneider as an employee there.
Yeah. So I think that's a good inflection point for me to just make that very clear. You did use the Schneider logo on the thumbnail for the stream. This is not sponsored by Schneider. It's not. I'm not mandated by Schneider to speak here. I'm here speaking just as an engineer who's been with Schneider for a while and has a fairly good view of what's available in our tech stack. And what
Schneider told you? You did tell.
Yeah, so I went and asked for permission to appear on the stream, and I was given 2 instructions. The first one is make it clear I'm speaking as myself. I'm not making any statements on behalf of Schneider. That's the first one. And the second statement was be honest. So even about the bad stuff, the not so pretty stuff, be honest. And so that's what I'm here to do. I'm here to be honest.
So I want
to kudos, by the way, to Schneider.
Yes, kudos to Schneider for, you know, and I said this in the pre-production to Mark. You know, I've had, when someone from Rockwell Automation reaches out to me, okay,
they're like, I can't come on the podcast.
Yeah. Here, in general, this is what people from Rockwell Automation say when they reach out to us privately. Okay, and we've had a lot. Okay, by the way, there are a lot of people from Rockwell watch our stream. Okay, they generally say, I agree with everything you say, and I can't come on. They basically say, I totally agree with everything you say, I can't come on. Mark did not say that. He did not say, I agree with everything you said about Schneider. And in fact, what he said was, here's my experience. There are some things that you've said that I agree with, and there are some things that you said I definitely don't agree with, and here's been my experience. And so we decided to invite him on. We had a private conversation, and then we had a pre-production conversation. So we've talked a couple of times. And you know, at the end of this stream, I'll kind of explain where my position stands on Schneider, and Mark knows what it is. I did tell him what my position is, but I want to lay the groundwork for those of you who don't work in the Schneider world. By the way, if you're in industrial automation, you're using some Schneider product. I assure you, it's very, very difficult to go into any facility and find nothing from the Schneider line card. Okay, but here's one of the challenges at Schneider. And it's through M&A. Schneider does a lot of mergers and acquisitions, okay? But here's just a list of some of the PLCs. This is not all. This is not an inclusive list. This is level 1, so we're doing level 1 here. And this is just a list of some. So the M580 EPAC, the M340, the M262, which is a new IoT application line, the Quantum, the Premium, the TSX Micro, the TSX Nano, the Atrium, and the Momentum. That's just a small sample set of what they offer. Here's
Quantum. Is Quantum still being sold today?
No, that's legacy now. It's end of life. Eh?
Those are insane controllers, by the way.
Supported. There's still a large install base of that, but so we do support it in some way, but no, it's legacy now. We don't actively sell it anymore.
They're like this big.
Here's another example. Just HMI SCADA. Okay, and this is a small list. So you got Harmony, you got Magellus. Everyone should be from, you know, Magellus is basically panel view, right? Magellus is in fact, I prefer Magellus to panel view. Viejo designer, EcoStruxure GeoSCADA, which, by the way, if we were going to compare what offering does Schneider have to say that's comparable to Ignition, it is the GeoSCADA environment. Okay, it's the EcoStruxure GeoSCADA environment. Now,
you wouldn't say the Edge. You wouldn't say Aveva Edge is because of its Indusoft roots.
If I had to pick just one, okay, if I had to pick just one, okay, I would pick GeoSCADA. Yeah. By the way, and here's why: GeoSCADA is in the Schneider world, in my opinion, it is the platform for solving problems, and that's what I refer to Ignition as, platform for solving problems. Now, someone at Schneider is they're not gonna say that they agree with me on that piece. They're gonna say, no, you need to look bigger in terms of the platform for solving problem. Don't limit it to just GeoSCADA. But for those who want to talk apples and apples, that's what
I would be one of those guys that disagree with you, by the way.
System platform and clear SCADA, right?
SciTech SCADA, it looks like is now called AVEVA Plant SCADA.
Correct.
Right.
So part of this mergers and acquisition story has been we've been renaming products like crazy, and every year you would find a whole host of stuff that was renamed. Some of the products that you mentioned, Walker, are actually the same thing. It's just with a different label on it. Right. So yeah, but yeah, you're right. We've got a very wide offer, and it has been through mergers and acquisitions.
Go ahead, Zach.
Well, Rick asked why not system platform.
Well, and I did. Oh, why not system platform as a platform for solving problems?
Potentially, yeah. Yeah.
The answer is here's why, Rick, to answer this question.
Rick was the product manager, right?
Here's why.
Chief Technical Officer.
Yes. So in order for you to be a platform for solving problems, okay, and we'll get into the leadership discussion here in a second. In order for you to be a platform for solving problems, there are some very important elements, okay? Number one, you have to have the mindset that if I have a 100% install base of whatever platform we're talking about, only about 10% of that install base is paid. 90% of it is research and development unlicensed. It's people using your platform to test ideas, but they're not minimum viable product yet. They're not on the plant floor yet, and therefore they're not paying for licensing. So you have to have a land and expand model, number one. AVEVA system platform does not have land and expand. You have to go and pitch an idea, and you're going to get that license for maybe 30 days or 60 days. So A, there's no land and expand. Number two, from a development perspective, at its base level, it has to be as easy as possible to work with. So that is, it has to be no code, low code, drag and drop. Okay. So you have to be able to put someone into a development environment, show them where data is, and they have to be able to drag data onto a window. Okay. That's number two. And number three, at the high end, there can't be any limit to what you can build. So you could basically build anything in it. And while AVEVA system platform definitely almost meets number three, definitely does not meet number two. It is not low code, drag and drop. Okay. In InTouch, you could make the argument that Wonderware InTouch was that way. Even though it wasn't drag and drop, it was easy enough to take a tag and get it onto a window. But system platform is not that way. It is all object driven, right? So you have to first build the object before you can ever visualize the object. Okay. And so that's one of the limitations of system platform. But the bigger piece is it is not a land and expand model. That's why. That's my piece. SCADA, by the way, you will notice meets all of those requirements except for the land and expand piece. They don't have a mechanism to just get it in everyone's hands. But if you get it in your hands, there's no limit to how long you can play with it. So those are the qualifiers there. Let's talk about the M&A piece here, Mark. So
sure.
Most people know that Schneider, they own a lot of companies. They bought a lot. And I would argue that probably the biggest acquisition has been AVEVA. Obviously, that was the biggest acquisition. AVEVA owns Wonderware.
The biggest in my mind was when Invensys bought Wonderware, and then Schneider bought Invensys, because that rolled the Wonderware system into. Correct.
But here's the point.
But AVEVA was probably bigger by
Correct. AVEVA was a larger. Invensys buying AVEVA it was an example of David buying Goliath when it came to potential. Okay, when it came to potential market viability. The second biggest piece is AVEVA acquired OSI Soft. So you have AVEVA, which acquired OSI Soft, and through that acquisition made it part of the Schneider ecosystem. So most people know Schneider, AVEVA, and OSI Soft. OSI Pi is now part of the Schneider ecosystem. And one of the questions that I asked Mark when we first talked was, okay, OSI Pi wanted to be the stack. Okay, OSI Soft wanted to be the stack. AVEVA wanted to be the stack. And Schneider has offerings everywhere. How do you reconcile that from a leadership perspective? So we had this conversation, right? So how do you reconcile if OSI wants to be the stack, AVEVA wants to be the stack, and Schneider's got offerings everywhere? And we had this discussion about leadership. So Mark, I'm going to turn it over to you, and let's talk about all the leadership changes that have been going on across that, and kind of what does it look like today, and how you believe that's going to funnel to a more cohesive approach.
Yeah. So in the Netherlands, there's a saying that loosely translates to you've just mowed the lawn in front of my feet. You've cleared the way for me. You've put a lot on the table.
Yeah.
But I'd like to take just a slight step back and ask the question: how does someone become the CEO of a company like Schneider Electric? Right? It's not a fight to the death. It's not a popularity contest. It's not like how politicians get elected where everybody votes and the guy with the most votes win. It's 100% strategic, right? The CEO that gets selected for a large company like Schneider Electric gets picked by the board, by the executives. They select the guy and they say, this man has the right skill set and the right focus to enact our strategy, right? And if you then add to that the stepping aside of Jean-Pascal, who's been in leadership of Schneider Electric for 2 decades, he's not leaving the company, right? So it's not like Jean-Pascal decided, well, he's had enough of Schneider and he's going to chase some other dream. He's still the chairman and he's still with the company. But Peter Herwig is taking over as the CEO. So those two things, I think, are very significant and should tell you something about the fact that change is coming to Schneider Electric, right?
Hey, let's talk
change in strategy and therefore now change in CEO.
And let's talk a little bit about Peter's background. So Peter was he was a Schneider guy who went and led AVEVA, and then...
Well, I'd like to go a bit further back than that, right?
Yeah.
The first thing that struck me when I went and looked at his career is he started off as an electrician.
Yeah.
Right? Came from tools.
Yeah.
And when I see stuff like that, it really gets me excited. He then qualified as an electrical engineer. He had a very long tenure at Siemens. He was there for, I think, 22 years. Started off, or did, software R&D in motion control, right? So very technical type stuff. And then basically worked his way up to become the CEO of Process Industries and Drives in Siemens before he joined the executive team at Schneider Electric. So the first thing that gives me a very warm, fuzzy feeling about him is he's an engineer, so he speaks my language, right? And the second thing is he's come through industry, right? If you look at you just had it about the product basket, but if you look at the businesses that Schneider, or the verticals that we operate in, it's data centers, it's building automation management, it's energy management. Even that is quite wide. So the fact that our current CEO came through the industry business unit gives me a very comfortable feeling, because I'm an engineer in the industry BU. So I already identify very strongly with our new CEO. I just quickly give you the history about Caspar as well. 7 years at Accenture until 2005, then 11 years at Cisco until 2015, then came to Schneider Electric, also from the industry business unit. He was there for 6 years, and then Caspar and Peter both went to AVEVA at the same time in 2021.
Peter was CEO and Caspar was COO.
Correct. Right. And now that Peter has come back to Schneider, Caspar has moved up into the CEO role of AVEVA.
So let me ask you this question. So since they were both senior executives, well, they were in the executive leadership at AVEVA, but both had backgrounds, prior to that. Should we assume that now the former CEO of AVEVA, who's now the CEO of Schneider, and the former chief operating officer of AVEVA, who is now the CEO of AVEVA, that we will see more of AVEVA in Schneider, or do you think it'll be more of Schneider in AVEVA?
Right. So exactly that. in preparation for this call, I went and consumed a lot of media about them, interviews that they've had, especially their first interview since they started in their CEO roles. And the message that you get from both of them is exactly the same, right? Firstly, they say that key priority, and it should be for all business, of course, is customer focus, right? There's a recognition that in this period of growth that we had through mergers and acquisition, we've created a bit of discontinuation between all of our different offers. The dealing with one Schneider business unit versus another is not 100% homogeneous, right? There's a strong drive that starts with their leadership to unify not only our offers, but also the way we do business internally, right? I think the most surprising thing I heard from Peter Hervik's interview was that we've got somewhere like 70 different ERP systems in our ecosystem, inside our own company. Our own data infrastructure has got 70 ERPs. It's ridiculous, right? So as we're preaching digital transformation to our customers, we're busy with it ourselves. And as you've said, it's not a project that begins and ends. It's a strategy, right? So we're looking at our entire internal systems, logistics, warehousing, manufacturing, everything. And there's a strong push towards unification. When it comes to our product basket, exactly the same is true. I've seen some product roadmaps that unfortunately I can't spill too much about because it's all confidential and internal stuff. But at all three layers of our stack, apps and analytics, edge control, and connected products, over the next 5 years, things are going to be extremely interesting at Schneider because there's a strong push to unify all of those product baskets. So Rick Bellotta pointed it out in Discord last year already. He said, early this year, he said Schneider/AVEVA is in strong need of unification of our offers. Definitely, the Schneider leadership is focused on it.
Here's my opinion on Schneider. I'll go ahead and give it now. I'm actually going to answer. I want to talk on messaging and MQTT real quick because there's a lot of questions about MQTT as it relates to SCADA and the Schneider offerings. So, number one, if you look at Rockwell Automation, right, in Rockwell Automation, there is a disconnect between Rockwell's strategic focus and where the market is going. And that is by design. It's coming from the boardroom. At Rockwell Automation, it is coming from the boardroom as a directive that we use our offerings across the stack to get people to buy more Rockwell offerings. And we make strategic decisions to make it hard for you to use a Rockwell product with a non-Rockwell partner, okay? We don't make it impossible, but we try to put just enough of a barrier to steer you back to Rockwell, and that comes from the boardroom, okay? Yeah. I do not believe that that's the case at Schneider in any way, shape, or form. In fact, I think from the boardroom at Schneider, it is what we'll do is we want people to build the best solutions. And if we have the best products at Schneider, they're going to use our stuff. Okay. Yeah. And I believe that that's their strategic focus. Yeah. The problem at Schneider is the left hand doesn't know what the right hand is doing because Schneider is so big. It's so big. And I think from a strategic focus, they need to focus on unifying messaging, strategy, and execution at Schneider. That's what I believe at Schneider. But go ahead, Mark. Sorry.
Yeah. So you took the words right out of my mouth. That's exactly what's happening at the moment. And so I've not seen any specific roadmaps or strategies or anything. I don't operate at that level. But from the conversations that I've had, I've got one or two friends that do operate at strategy level. I've got contacts into the business via management as well. And I take two things away from the two CEOs that we've got and what they've said. The first one is they both happen to be German. And an interesting thing about Kasper is he also spent some time in the German military when he was a young man. Both of them bring German discipline, right? And I think that's going to filter through the entire organization. And the last thing is if if the last decade of Schneider Electric has been growth through acquisition, I used to joke and say Schneider's philosophy is if you can't beat them, buy them. Okay.
Yeah, I still say that.
it's way more strategic than that. That makes it sound very simplistic. Like, oh, they're competition, we just buy them. No, the companies that we have acquired through the last decade have been strategic, be it for the tech or the people or the customer base, right? There's been a strategy behind it. And I think the change from Jean-Pascal to Peter and Caspar as well is a signal that where the last 10 years, the last decade, we've been outwardly focused, pulling in technologies that we didn't have, trying to get all the building blocks that we need to answer any problem. The next 5 to 10 years is going to be focused inwards, structuring all of that, unifying it, and making a cohesive message out of all of it.
So
that's my takeaway.
I want to pivot to the OSI Pi to segment 2, the OSI Pi discussion. But I wanted to, there's always, if there's one question I get from people when they ask me my opinion on Schneider as it relates to unified namespace and, everything we teach about successfully digitally transforming, like in open ecosystems, they'll always say, which of Schneider's offerings support MQTT? Which ones support Spark-Plug-B? Which ones? And let me say this: it is very difficult to answer that question for a lot of reasons. But most of it has to do with Schneider just has so many offerings. They buy so many offerings. I'll just give you a couple of the examples, though. The 2 examples I give the most, if you're asking about MQTT support, one of the glaring omissions in GeoSCADA is the limited support for MQTT and GeoSCADA, and by limited I mean none, but you can make it possible. But here's my example. If you look at Schneider, say GeoSCADA, then you compare EcoStruxure Machine Expert, and then you compare AVEVA Insight, and then you compare OSI Pi, all of which support MQTT, and all of which support MQTT differently. Right. So if you look at EcoStruxure Machine Expert will produce and consume. So it's one of the few offerings that allows you to publish and subscribe from agnostic brokers. But if you look at, say, OSI Pi, which is probably, we're going to pivot into OSI Pi because that's representative of how a lot of other Schneider solutions handle MQTT. They handle it as ingestion only, as opposed to ingest egress. Okay. What OSI Pi takes the same approach. We consume via MQTT, but we don't publish back into an ecosystem, right? What I want to do is I want to talk about OSI Pi, the AVEVA acquisition of OSI Pi. What does that mean about the future of OSI Pi in terms of your perspective? Okay. And then number 2, let's talk about the discussions you've been having internally, because OSI Pi has been, or AVEVA has been soliciting feedback from the community on how they want to see, what do they like about OSI Pi, what they don't like, what feature sets do they want to see. And what I want to do is turn it over to you about all the discussions you've had as it's related to OSI Pi. You know all the questions I'm going to ask. I'm just going to turn it over to you.
Sure. I just want to take 2 seconds to defend GeoSCADA, because it happens to be my favorite SCADA product inside our basket. But I think it has a very nice MQTT Spark-Plug capable driver, also capable of building tags from metrics automatically, all of that good stuff. But yes, it only ingests data, it does not publish. So there we have a problem. Okay.
Yep.
Okay, OSI Pi. So I had to go and educate myself about what OSI Pi is after our first conversation about it, because I've never touched it. So also, whatever I say now, take it as secondhand information. I may make 1 or 2 mistakes here or might misunderstand small topics, but I have done my best to try and educate myself. OSI Pi, I spoke to a sales consultant at AussieSoft that basically does the same thing that I do. And I asked him some questions. I said, what can we do with MQTT inside OSI Pi? What future developments are there in the roadmap, and how can we take data from OSI Pi and put it into a UNS and that kind of stuff. I wish I had the answers that you wanted. I wish I could tell you that, yes, in the very near future, Aussie Software is going to release an adapter or a connector that's going to publish data out via MQTT as well. Unfortunately, that's not the case. The message that I got was, yes, they're very happy to consume data from an MQTT broker because they see that as an OT data source. But they do not want to position OSI Pi as just another OT data source. So they feel uncomfortable with the idea of publishing data out via MQTT. But they say that there's a whole host of other ways that you will get data out of OSI Pi via, let me just find my notes here. The SDK, the API, and the extract, transform, load, plug and play interface that they have. I argued the point a bit. I said to them, well, the customers that I'm talking to, they have a unified namespace. You can stream data from that unified namespace into Pi. There you now put the data into an asset framework and then do some calculations that produce metadata about the objects in your unified namespace. The expectation is to take that data back to the unified namespace. And then we had a bit of an argument about, yeah, but where should the UNS lie and all of that kind of stuff. Well, customers that I'm talking to, the UNS is outside and OSI Pi is just another application in the ecosystem. Whether it's OT, IT, it makes no difference. The UNS is where all applications go to access any data about the entire enterprise. And so there was a bit of a disconnect. It's not ideal. There are other ways to get data back into the UNS via MQTT. There are third-party adapters or connectors that you can use that act as a translator. They access the OSI Pi data model and then publish into the unified namespace over MQTT.
Like HiByte will do that.
Yeah, right? One of the things. So there's a Pi system connector in HiByte, and we were talking about this in the pre-production, that the way that we currently so I'm going to quickly from a high level explain what the OSI Pi stack is. Okay, so you have an OPC server. Okay, you got an OPC server that's serving out OPC objects or items into the OSI Pi historian. Now, you can store that stuff raw. You can just basically take the tag from the PLC and drop it straight into the historian, which you generally do. But one of the other things that you do is you create asset frames where you organize together, you do data modeling or information modeling in asset frames inside of OSI Pi. Asset frames are like, for those of you who do PLC development, they are like user-defined data types. You are basically grouping together many different data points into a structure that provides context. So you may have an asset frame that is a pump. You may have an asset frame that is a tank, right? Those asset frames then can feed into event frames that will then take those values and transform some of those values into new KPIs, okay? And then you can do analytic, you can plot those on dashboards, you can put them in time series charts, you can do lots of cool things with them. Here's the problem is that, I want to say the problem. The challenge we face using OSI Pi as opposed to using another historian that supports MQTT out of the box is that you can't take an asset frame. So you have two things in an asset frame, which is an object. You have the definition of the asset frame, and then you have all the instances. So right now, if what you want to do is extract that data from OSI Pi using, for example, the asset frame SDK, which is really how HiByte does it.
Yeah, deterministic.
It's deterministic. You have to know all the instances that exist. So you can't, if I create a new instance, it can't just be pushed into the unified namespace. So ideally what you would be able to do is know all the definitions that exist inside of OSI Pi, all the definitions of an asset frame or an event frame. And then you could just say, for every definition, give me all the instances. And so if I created a new instance, it would return. Right now, that doesn't happen. It's deterministic. You have to know what's there. It's problematic, obviously. That's not edge.
It seems like the SDK in that interface wasn't built with edge-driven and plugging into a unified namespace in mind.
Correct. Exactly. And so, and then there's somebody else asked about, I just want to answer this question here. Can't be the UNS from my perspective.
That's exactly what we said.
Yeah.
Like what
Luke Resnicek, yes. Yeah. So, and by the way, Mark is in agreement here. Pi asset frame cannot be the UNS as we define it. Okay, as what we teach as a unified namespace, Pi asset frame cannot be the unified namespace. Not only is it not scalable, it isn't scalable, but more importantly, it won't cover every use case in your organization. So it won't cover every functional use case. Therefore, you'll have to leave solutions behind. But there was Gatfi said, can you give a few more details about MQTT and other technologies you talked about? Because there's a lot of people that never heard about them, and thank you. Okay, real quick, MQTT is messaging queue transport telemetry. It is a technology, and this actually will segue into OSI's strategy as it relates to MQTT. They view MQTT as an OT protocol, and that's part of what's driving there. But MQTT is a technology that was developed in the late 1990s, 98, 99, and it was developed in conjunction by a guy named Arlen Nipper and a guy named Andy Stanford Clark from IBM. They were working with Phillips 66, and they were working over serial networks, and they were trying to collect millions of data points over a serial network, okay? And they created a whole new protocol that was edge-driven, publish, subscribe. So report by exception. So basically, the device on the edge is pushing the data and only the stuff that changed. MQTT, everybody is familiar with MQTT. If you're using iMessenger on your phone, like your Apple phone, when someone's texting you and you see the ellipses, that is you being informed through a broker that they're typing. They use MQTT for iMessenger. They use MQTT for Facebook Messenger. It is a very, very popular IIoT protocol that was originally developed for industry, but really didn't take hold in industry until like 2013 or 14. So for the first 15 years, it was on the commercial side of the world. But what I wanted to point out is,
and if you're like me and you're not on Facebook, right?
Yeah.
But you have a Netflix subscription, you're also using MQTT.
Yeah. So, but one of the issues is that from at least the OSI group views MQTT as an OT protocol, and it's meant for OT ingestion, basically, right? And it's not meant to be it's not a protocol that they don't view it as a protocol for your digital infrastructure of the business where you have OT-IT convergence, right? I wanted to say one other thing because I want to give Schneider credit here. Earlier on, we were talking about OSI Pi and asset frames. And so, Zach had said, well, isn't that really digital thread? And I said, yeah, well, obviously it is. It's a digital thread. An asset frame is a digital thread. But Schneider, OSI Pi actually does digital thread right, okay? There's nothing wrong with digital thread on a use case by use case basis, as long as when you create the digital object, you do one of two things. If you create it on the edge, you make it additive. That is, as information is created from the object, you can put that information, you can publish it back on. And so as it moves up the stack, when it gets to the data lake or the data swamp or whatever data, lake house now they call it, it is fully contextualized. Okay. You didn't have to leave anything behind. You do it that way. Or what you do is you don't create the thread until all the context is done. So, and OSI Pi tries to do that approach where you take OSI Pi, which is where OT-IT convergence takes place, and they create the asset frame there. That's after supervisor control, data acquisition, and manufacturing execution. So you could create an object that has all of your OT context in OSI Pi. And it is one of the things, they do it right. They create the thread in the right place. The problem is exposing the data and information outside of Pi.
And that's why I said digital thread, because I remember you did the AWS digital thread video. You talked about how digital thread is like you're threading it up to the cloud, and then you're unlocking value out of the cloud. Right. And in the same way, Pi is similar, where you're getting it into Pi, and then you're unlocking value typically out of Pi.
For what do you, Mark? What do you see as the future of OSI Pi? Based on your conversations, what would you expect to see for the next year or something? If you can share that, I didn't know if that was
so. as for what's on their R&D roadmap, I don't have any more view on it than perhaps you have. There are two links that I want to make reference to.
Okay.
But what I can say is, as part of the whole product offer unifying exercise that's kicked off this year at Schneider, one of those, the top layer of the EcoStruxure stack, which is apps and analytics. Over the past 5 years, we've had products pop into that layer called advisors, right? We've got machine advisor, asset advisor, product advisor, and they popped up, in my opinion, like little mushrooms, right? But each one of them were in their own little niche application. I think the most curious one I found was pumping performance advisor, for example, which is
Josh, real quick, can you share that slide? It's the EcoStruxure for Industry slide in the notebook. Go ahead, Mark.
Yeah. So, but each one of those advisors was its own little cloud platform, its own little niche application that wasn't representative of your data throughout your entire ecosystem, right?
Right.
So even if you look at this slide now already, if you were to find this slide from, say, 3 years ago, that top layer would be way more populated. There would be like 9, 10 different advisors all in that layer, and you'll notice it's a bit less crowded there now.
And is that because the expansion of EcoStruxure, where they're doing consolidation through EcoStruxure?
Yeah. So that apps and analytics layer, the exercise that's happening now is a lot of those advisors are shifting over to the AVEVA side. Okay. And the two platforms that are highlighted as potential replacements for the current advisors that we have are AVEVA Insight, if it's a very basic, not too technologically intensive cloud platform or cloud application. And for the more complex type stuff, it's AVEVA Data Hub. And Data Hub comes from Aussisoft, right? It comes from the OSI Pi stable. My view on Data Hub at the moment is it's a bit bare bones. It's very complex. There's you need a couple of guys who know data ops, who know what they're doing to engineer that for you. But I think what's going to happen over the next couple of years is, as Schneider is looking to migrate these advisor portfolios or advisor products over to potentially Data Hub, that we might start finding some out-of-the-box applications where, if the appropriate data is present in Data Hub, you can plug an application on top of it that is a machine advisor or an asset advisor, etc., etc.
Let me ask you,
that's where it's going.
Let me ask you that. I know this wasn't on the topic, but I just came up here. Which is here is a very common. Let's say I get brought in, or one of our architects gets brought in a pre-technical sales, or so pre-technical or technical sales role, right? So what we're doing is we're doing the evaluation. We know what the business problems are. We're getting the lay of the land. We maybe be looking at one plant, and we're going to go ahead and put in a digital infrastructure through which we'll start building solutions. Okay. So here's a very common architecture that we do. We will at the plant level, the first thing we'll do is install Kepware to talk to all of the PLCs, all the industrial hardware. Then what we'll do is we'll install HiByte, which will consume from Kepware and give us our data ops mechanism. Then we will install as a IIoT platform, either Ignition or Factory Studio, or depending upon what our specific needs are. We'll get that installed at the plant level. We'll connect to it. We'll connect to a database, and we'll drop a historian in. And generally, the historian would be, say, Canary Labs, because it natively integrates to what we're doing, right? Okay. And then what we do is, the first thing we do is we just acquire all the data and we model it based on the business model, generally ISA 95 Part 2. And then what we do is we solve a problem by saying, okay, we have all the raw data. We got the stuff from the PLCs. We've got the work order from the MES. We've got the manufacturing order and the bill of materials from the ERP. And we got to create some solution. And we're going to build a functional namespace, and then we're going to visualize that. The human being's going to interact with it through a dashboard built in Ignition, and that is consumed from, you know, basically HiByte is the one that's connecting to the ERP, connecting to any existing infrastructure, and Kepler is talking to all the devices. When you're going in and you're doing the same thing, but you're doing it through, hey, I work at Schneider. Could you give an example of that, what that would look like, what suite of solutions you might recommend that is a combination of, say, Schneider and or not Schneider solutions? Is that something you, hey, generally we're using this for connectivity, we're using this for modeling, we're using this for platform.
Best in class?
Yeah.
I'm hesitant to put myself on a pedestal and say, well, all of this that I'm picking out is best in class. I certainly don't have your breadth of view, and I also have to caveat that the industries that I've worked in are different than yours.
Right.
I work in water, I've worked in mining, I've worked in heavy industry. Right. You're more focused on discrete manufacturing, packaging, that kind of stuff. Right.
Yep.
Slight different nuances in those industries, but the SCADA package that well, I'll start at SCADA because PLCs can be anything. It can be Schneider PLCs, doesn't have to be. Every SCADA package out there has 1,000 drivers and can connect to anything. Like at least any good SCADA package has enough drivers to connect to anything. The SCADA software that gets put at the edge control layer is AVEVA system platform from us. There are some technical reasons why GeoSCADA doesn't always make it there. Okay, GeoSCADA is very particular for telemetry. Yes, object model or object-oriented, very easy to engineer. But there's certain performance limitations inside GeoSCADA that means that I can't position it as an enterprise class type SCADA that will do everything kind of thing for you. So AVEVA system platform is the SCADA of choice.
Okay,
that's and as you pointed out, that it brings with it some engineering complexity, but it does bring with it an object model.
Yeah, it gives you connectivity, it gives you object modeling, and it gives you platform. Gives you all three in one. Okay.
Yeah. If you then start looking at Historian, the Wonderware guys, I call them Wonderware guys because they have Wonderware history, tend to go for Wonderware Historian. What I've found at the customers that I've been talking to, 90% of the water customers in the Netherlands are using OSI Pi.
Okay.
Right. And that has the ability to recognize the object model that's in system platform and translate it across without having to do engineering. Right. Yeah. And then you start doing your additive, you're adding data to the object model and expanding it as you go, starting to go up the stack.
And I just want to point out what Francois put in here. So this is actually a good architecture, which I would have outlined as well, is AVEVA Edge on the edge, which is the old Indusoft. But AVEVA Edge on the edge, MQTT broker to the AVEVA data hub, and then twin thread back into the data hub. So that gives you an analytics layer on top. That's the issue here is Edge is not, Edge isn't, I would not call AVEVA Edge plant level. I would call it like line or area level.
Okay. It feels to me like we're starting to digress into the next topic. And before we go there, there's a very important thing that Josh, if it's possible for you, the two links that I shared about the feedback pages for OSI Pi and also for Data Hub, right? This is what I have to say. This is my call to action for you and your community, right? Is go on to the feedback page at AVEVA, right? It's datahub.feedback.aveva.com and pisystem.feedback.aveva.com, right? It's in the link or in the description. If you go on there, you find a page where people can propose ideas of things that they want inside OSI Pi or in Data Hub, right? And you can search through those ideas. You can see which have been completed, which are in progress, and which they're asking for more information. If you search for MQTT, and you can vote on it. Users can vote and say they like this idea. And obviously, if enough people vote on it, then the developers take note and they start actioning it. If you search for topics on MQTT, you'll find some, but they've got very low votes. And specifically, there's only one request to have Pi data published to an MQTT broker, right? Only one. And so far, I think it's only got 7 votes. And you can comment on it. So the first comment was, Pi need to do this to stay relevant by an anonymous user. I'm the second guy that commented on it. I said exactly everything we just said, where we want to get data from Pi back into the UNS, and it has to go via MQTT, right? Please, your community, go there, go vote for that topic, and please add your comments, because I think you can do a much better job of explaining the use case to the developers than I can.
Let me, real quick, I want to, this ain't my real name, who, very nice handle. So your question, hey, Walker, about this example you just gave, basically you try to capture as much raw data from as many PLCs as possible, and then you think about how to use it, never the other way around. Let me answer that real quick, just because we're going to go over. We have one more topic to cover, which is an architectural topic, which is the most important topic we're actually covering. So, but if you can't stay, I want to make sure everyone hears this. I cannot stress this enough. Okay. I cannot stress this enough. In our conversations with SAP, with Salvatore Castro, when he's on in a couple of weeks, the place that he and I are going to disagree the most, okay, is SAP and most of the legacy organizations argue that you should only capture data you have a specific use for. Okay. That is preposterous. If what you want to do is, if you look at the organizations who are most digitally mature and who are basically killing everyone, I don't know if you guys noticed, but Ford waved the white flag and said, we give up, Tesla, you won. I mean, that's literally what just happened last week. Okay. And we want to ride on your coattails. That's literally what Ford just did, because they know that Tesla is gaining 5 years on them every year. Every 1 year, now they're moving ahead 5 years, every 1 year. How did Tesla do that? What it is they made data their primary commodity. And I've said this many times, and there's a machine learning post we did. There's 2 steps in machine learning. Step number 1 is the easy stuff. You could hire somebody who barely graduated with their degree in data science and ask them to write you a linear regression between 2 data points, X and Y, and they're going to be able to do it. That is testing a hypothesis you came up with. I know there's some relationship between X and Y, but I can't mathematically prove what it is. I need someone to do that. That's the easy stuff. The real important part in machine learning is using raw data to find patterns in the data we can't see with the naked eye.
What's Schneider's AI play? Like, what is their AI platform?
We'll come right to that here in a second. But the point is, all data matters. All data matters. In order for you to take the second step and use clustering to find patterns in data we can't see with the naked eye, and then use other algorithms to determine whether or not that is actually a relationship or it's an outlier, okay? You have to collect everything. It is absolute pure hubris for you to think that you know all the data points that matter. Okay, honestly, it's pure hubris. Okay. Anyway, Mark, let me turn that over to you. What is, in your opinion, Schneider's AI play?
Zach, unfortunately, I don't play at that level, so I'm not in touch with the R&D guys that are developing the AI. It's pretty much all in AVEVA stable, right? Because they play with the data platforms and the cloud platforms that we have. I have heard that artificial intelligence is going to become even more pronounced in the offers that we bring in the future. So it is a big part of our strategy going forward. What it entails exactly, I'm not the guy to tell you, unfortunately.
Yeah. Okay, fair enough.
Conversation number 3. So this is the
we should have John. Would you have John or Peter on the podcast? Maybe he'll come on.
Well, you wouldn't. You want more the product owner.
Well, let me ask you this. If Peter were to come on, what would you ask Peter then?
Me personally?
Yeah, what would you ask Peter?
Oh, what his values are.
New CEO of Schneider.
Yeah, I'd ask him what his values are. That'd be question number one. The question I ask every CEO is I ask them two questions. Okay, number one, they never expect me to ask these two questions, by the way. But question number one is, what are your values? Like literally, what is it do you value? If I get the deer in headlights look, then I know what they are is they're focused on the P&L and they're quarter to quarter, and that's what they are. So question number two is, do you believe that the executive leadership in your organization are the smartest people in your organization? Like, do you believe that you have all the answers, or do you believe your job is to create an environment that enables the people who have the answers to realize the solution to those answers, those questions? And those are the two questions I ask every chief executive. If you're ever going to come in front of me, you should definitely be be prepared to answer those two questions. So Mark, let's talk about number 3 here. Okay, so topic number 3 is we want to have a discussion about server-centric development. So think centralized data hub in the middle, and you kind of build everything in there, versus a combination of, you know, edge-driven deterministic development. Mark, go ahead.
Not 100%, but in consuming all your media, I really started having a bit of a frustration with the term "don't be deterministic."
Deterministic,
right?
yes.
Yeah, don't be deterministic, right?
Don't be deterministic with data.
Yeah.
Right.
Okay.
Yeah.
But it sort of struck me that, because I'm an engineer, I'm a nuts and bolts kind of guy. I don't like vague, opaque pictures. I like to see every single detail. I like to be deterministic, right? And so in the industries that I've operated in, the design approach, especially between PLC and SCADA, has been one that is extremely deterministic. And it is, in fact, it's commonly described as a hybrid DCS approach. Mm-hmm. Okay, so I'm here to make a case for that at the hand of an example. Joshua, you're welcome to put the graphic that I sent you earlier today up on the screen. Yep. I'm going to talk around the background first, and then we'll climb into what's on screen at the moment.
So let me qualify real quick, Mark. So you made the hybrid DCS. So I want to explain that for people who don't understand that. So
I'll explain it, okay, if you'll allow me. Okay,
go ahead.
Right. So DCS is an extremely deterministic kind of automation strategy where, yeah, it's distributed control system, but everything, be it the graphics, the data, and the control algorithms, are packaged up into objects. Okay, and before you begin any DCS project, you begin with a template library where you define the objects, what data is inside them, what the graphics looks like, alarms and events, trends, blah, 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 all get packaged into an object. And then when you develop the control system for a process, you go and instantiate objects from those templates, right? Hybrid DCS is simply taking that exact same approach, but what gets pushed out at the end of the day is not a DCS system like a Foxborough or an Emerson DCS system. It's still a PLC and a SCADA application, right? So the runtime of your DCS application that you built is a logic application that runs on a PLC and a SCADA application that runs in AVEVA Plant SCADA, AVEVA System Platform, whatever you want, right? So that's my explanation of hybrid DCS. Is that good enough for you, Walker? Do you want to add?
Yeah, I would just say, I would say from a DCS perspective, and I've had a lot of people arguing with me on this piece. DCS is two components. There's two important components of DCS. Number one, speed is of a priority. So there's almost always some type of field bus that connects all the hardware together. So you're getting super fast data transmission. That's number one, kind of, you know, taking the SCADA platform, the master, and all the slave RIOs and putting them together over some type of field bus rather than, say, Ethernet IP or whatever, right? Generally, it's some type of field bus so you get high speed. Number two, what you're doing is there's 3 layers of objects. And they all match each other. So object number 1 is the object for the process, and it generally lives in the DCS, may look like a function block. That's an object. That object then maps to a API object that allows you to retrieve it. I want to pull all the data from that function block or that object. And then you have a visualization object, which directly maps to the thing in the DCS. That is a different, in DCS, you always develop that way, as opposed to this hybrid approach where you have the option of developing that way or not developing that way, right? You could just, you could deterministically just connect everything together instead of dropping in the template that maps to the process object and say, and then it just visualizes it. So, yep.
So yeah, so if you need examples of hybrid DCS products, then Siemens PCS7 is one of them.
Yep.
Rockwell's Plant PAX is in the neighborhood, and Schneider has one called Process Expert. Right, they're all hybrid DCS products. Right, so exactly what you explained now about the logic, the data, and then the visualization is typically what you get out of a hybrid DCS system, that you define templates with all of those components in them, and when you instantiate the logic of how something gets controlled, be it a motor, a valve, an instrument, or some equipment module that lives over the top of a grouping of other objects, all of the logic gets generated for you. All the data interfacing to the SCADA gets generated for you, and all the graphical objects are you just drag and drop them onto the page and you're done, right? So in all of the projects that I've executed, that's been the approach.
Mm-hmm.
Okay. So another little contextual difference between the industries that you operate in and the ones that I do is if you look at the graphic that's on screen at the moment, the one thing you'll notice is absent there is HMI. Mm-hmm. There are no HMIs in that entire system. Okay, the HMI is the SCADA, and because the SCADA is your complete and entire HMI from which you do all your diagnostics, all your fault finding, sequence of events, everything, every single bit of data in the PLC, excluding like little flags and timers and bit of logical control type of data that's pertaining to how you put the program together. But object data, every single bit of object data that lives in the PLC, one-to-one is extracted into the SCADA. So when you have a SCADA system in front of you, all relevant data that you could possibly want about any object has been extracted out of the PLC and therefore lives in the SCADA. Okay. And there is so the question that I then ask, especially if you've gone and built a system like that, is it necessary for my PLC to talk MQTT? Where is the edge actually? Because all the data lives in my SCADA, and if I just needed to get that data into a UNS, my PLC doesn't have to do the transmission. My SCADA does it. So I point all my SCADAs into the UNS, and below my SCADA is where all the PLCs are. But that's,
and by the way,
yeah, that's beautiful.
By the way, I'm not making the argument. I'm definitely not making the argument that if assuming that the DCS environment has assumes, so here's a very important point. Everything that's in a distributed control system as it relates to object is function based. So that is, it has a functional purpose. You don't build the object without having a functional purpose, right? And that functional purpose could be process control. A function could be a PID loop, right? It could be temperature control as a function. All right.
Yeah.
So that all of that stuff matters, and that's all function based. So in the UNS world, we call that a functional namespace, right? So if we were to look at the namespace, we would have a functional namespace for each of those things: temperature control, PID. But you'd also have a functional namespace for the object itself. Okay, number one. No, and the object could be something like tank, or it could be in the steel industry, it would be something like a rolling stand in a rolling mill, right? You would have a object for a rolling stand, and then you would have sub objects for all the functional processes. All that stuff matters. But also there are other things that matters too. Like, for example, the state of the actual hardware, the IO, the data on the IO, the raw events on the IO. So, by the way, most DCS systems don't make that data available outside of the DCS system.
We do.
Right. But
we do.
But most DCS systems don't. So with you guys, what I would argue is, no, all you have to do now is put a layer on the side of the DCS, which is the layer that exposes through whatever our common protocol is. Say it's MQTT. We go DCS over MQTT into unified namespace. Right? That's what I would argue. If you look at what we do, and let's say it's not MQTT, let's say it's OPC UA, it doesn't matter what it is. My point is it needs to be IoT protocol, right?
Yep.
If you look at the most common DCS environment out there for us is going to be like Emerson Delta V, right? That's, you know, life sciences, that's the de facto. Also in heavy industry that we see that a lot, right? Basically what we're doing, we're never going out to the hardware and saying, hey, you need to add in MQTT support and transmit this. What we're doing is bolting on a layer next to the side, on the side of the DCS, and then publishing all that. But what we're losing are the raw events from the Emerson Delta V hardware, because that isn't exposed.
Okay, so with a Schneider solution, take Modicon M580 PLCs, that's very popular in the heavy industries. And hybrid engineering that with Process Expert, our hybrid DCS, and then using system platform as a runtime, by the way, which is a possibility. You could use either plant SCADA or system platform as a runtime. Yeah, one of the first templates that we have in our library is all the hardware events, everything that happens on IO cards, network cards, everything that helps you diagnose the hardware itself, nothing to do with your process, the hardware. Those are the first set of templates that you have in the library. And then, yes, then we go on to the process. So we don't only give you process data, we give you all the hardware stuff as well. And yes, if it is then in system platform, as we already know, system platform does have a bidirectional MQTT driver, Sparkplug B, and can then push all of that stuff into the UNS. No problem. Okay, Josh, can you put the graphic back on? I just want to make a case here, right? So if we look at this, I don't know how clear it is for everybody, but this is an actual customer of mine. I did not design this architecture for them, but this is the result of me sitting with them and getting, like, I'm coming after the fact, after they've done a whole series of projects and putting together what their data ecosystem looks like. Okay. This customer is a water utility in the Netherlands. They do three things. They manage the surface water, they collect the sewage, and then they treat the sewage and push out fresh water into the, or cleaned water into the water ecosystem, right? On the left-hand side, they've got the telemetry that is focused on the surface water management. And I don't want to focus too much on that because that's just typical telemetry stuff, pulling data from the field via, you know, GSM and all sorts of stuff.
Those like SCADA packs or something, or?
No. They use Phoenix Contact, I think. But it's pure one-way data. It's they're pulling in some information from sensors on the surface water. There's some actuators, but DNP3. I think they use IEC 104, but it's similar to DNP3. But that's not the interesting part, right? It's interesting to know they have 600 outstations in their network, but that's not what I want to focus on. They've got 200 pump stations. So if you talk to them, I mean, one of the first questions I ask them is, how large is your data ecosystem? Or, you know, how many systems do you have? How many sites? And the answer that I got is and on the sewage side, we've got 230 objects. I'm like, oh, 230 objects, that doesn't sound very big. No, an object is a site, right? So that's the way they think about it. A site is an object that is made up of sub-objects, right? That's how they approach it. 200 pump stations, 30 sewage treatment works. The way that they engineer this, right? And when I say they, I mean the customer themselves. They don't use system integrators. They don't use, they don't ask Schneider to engineer it for them. They do it themselves. Okay, that's the other important thing.
Why would you object it at the site level though? Unless these are exactly identical, it seems like that's more work than it's worth.
It's because it's system platform. I mean, when you're doing system platform development, one of the most ideal ways to manage your interface is to
number of screens.
Well, what you do is you create all your objects, and then you make all of them children in one big object, which is the visualization, and then you make that a series of visualizations that's a child of one object, which is the site location itself. It's a very common integration strategy with system platform. The challenge here, in the reason this really works, say in water, is because you go to any wastewater treatment facility, the process is the same. I mean, there are some deltas, right? But the process is the same. And so this really works exceptionally well in this type of process.
Exactly. So let's quickly talk about their engineering team. They do it themselves, right? If I say they've got 200 pump stations, 30 wastewater processing plants, and then on top of that, they have 3 different artificial intelligence packages that gives them predictive analytics, optimizes their process, and gives their operators assistance. So when an alarm or an event happens and the operator needs to know which button to go and click to recover from a failure, our AI is steering them, right? So they've gone and achieved that, not completely the holy grail of AI pushing data back down to the PLC, but it has at least entered the control room where the operators are leveraging AI to help them manage their system. And they've leveraged AI to optimize how their water pump stations and wastewater treatment facilities interlink and operate together. I saw a presentation of the gains that they made, be it energy, maintenance, all of that kind of stuff, and the savings. The financial benefit of how they've done it is staggering, right? They saved 40% on their maintenance budget just by controlling in a smart way how their pump stations operate, right? Okay. Anyway, so having said all of that, right, with the infrastructure you see in front of you, how large do you think their engineering team is? Take a guess.
Well, I would say. Okay, I think the default
3 or 4.
I would say it's smaller than that. You could do this with 2 people with this type.
Yeah, but it's a public utility, so
you could support it. But it's in Denmark, right? Or I would say.
Oh, okay. I'm thinking United States.
Yeah, no,
the operators I've worked with are not very.
I'd say it's 2 people. That's my. I'm going to say it's 2.
So their data ecosystem supports 100 users, right? The large majority of that is operations.
Well, I'm talking about the engineering. I'm saying the engineering group is 2 people.
No, I'm getting to that, right? So ops and maintenance.
Mark's like, I did this last weekend.
No, ops and maintenance is like 70 to 80% of the user base, and they have 4 software engineers that looks after this, right? And the only way that you can control or sensibly engineer a PLC SCADA application for 200 pump stations is to standardize and be very deterministic and say a pump station is a pump station, right? I'm not going to allow in instances of my pump stations circles and squares and triangles. No, from a maintenance perspective, spares holding, etc., and from a data ecosystem perspective, we are going to be deterministic and say this is a circle. End of story.
Right.
And we engineer.
You don't always have control over which contractor built pump station number 189.
But if you write the specification, right? But I want to say
ideally
they're using. But I want to say something real quick to just for the audience. One of the when we're looking at water wastewater use cases, another really good example for this where this is going to work great is like in green energy. So wind, solar, this is going to work really well because wind and solar, the object never changes. You're never you're not doing new products. Like in discrete manufacturing or in linear manufacturing processes, you have PLM, right? You're developing new products, you're now developing new processes. You need, you need flexibility and innovation. Here, you don't need that. What you need to do is to master the art of the process. The process is the process is the process, and it's not going to change. Right. It's
I come from the water background, and I did do a wastewater treatment or a sewage pump station, and it was actually a Modicon M340. It was, I will say, pump stations are probably sewage lift stations are a lot more standardized than like water pump stations, because water pump stations, a design and engineered build. The number of pumps is unique. The sizing of the pumps.
Yeah, but they don't have. They don't. But
so you're really kind of custom. You can't really model a pump station like you could.
But hold on, Zach, real quick. Let's talk about the differences between water, wastewater in the Netherlands and here. Number one, Netherlands is not a very big nation. It's huge.
Okay? Yeah.
Number one. So when we think of water, wastewater in the United States, that covers an enormous amount of space and lots and lots and lots of people. Number one. Number two, we are that approach to solving water wastewater solutions here in the United States is very corrupt. Okay, most of the people who are working on those solutions are on the take. The organizations they're greasing palms, and this is all well known.
Leaving code out of the
leaving code out. The approach that in the Netherlands, clearly the approach here is what is best. What is best. What should we do? And here in the United States, we don't generally, especially when it comes to the public projects.
Yeah, because I'm like, I did one pump station, and I know one sewer lift station. I know the number of problems that were on that one project. I'm like, there's no freaking way all 200 are the same. Like, but that's here.
But Mark, let's go ahead.
To continue on that, Zach. So yeah, even in their system, like pump stations do vary from one site to the next in sizing of the pumps and exact number
but it
of
still
pump
fits
trains
to the same model.
Exactly. And the model is also extensible. So for that outlier where you have a slight deviation, for the 1% where things are different, you can afford to extend the model and add the extra data, and that just goes into your UNS, and everybody carries on with it.
Our architecture here that we promote is designed to do abstraction at a higher level in the architecture because of all the deltas on the edge. To your point, determinism is very effective when there aren't a lot of deltas on the edge. Absolutely.
Yes.
1000%. And not only are they effective, it's probably the strategy of choice. Not probably. It is the strategy of choice. Okay. On the edge. All right. We have, Mark, do you have anything else you want to, we've gone way over.
So just one other small bit of context for your scenarios is you typically live with machine builders that bring a machine with a PLC, and it's very complex stuff moving inside, right? It's a complex piece of machinery, but the PLC is part of the machine builder's IP, right?
Yes.
So you have to write the minimum technical requirements that says, hey, I need this data from you
in this format,
pushed in this format, blah, blah, blah. And so you live with machine builders delivering machines, and then you have your system integrator that has to now try and get all of this stuff into a SCADA. And that's different from heavy industry and water, mining, etc. Customers typically have the capabilities to write software themselves, develop the PLC and SCADA applications themselves. And if they don't do it themselves, they have usually a board of system integrators. They control their standard. They say, if you are going to automate a valve, this is how you do it, and you get with the program or you don't work here, kind of thing. So the customer controls absolutely down to PLC code level.
Very few customers are like that here.
Well, but you got to understand, again, in the United States, our focus is innovation.
Only the customers that have worked with an integrator, like the ones that we work with, that have implemented that system on their behalf.
I get this question a lot. I want to take.
Don't have customers that have technical chops like that.
I get this question a lot. Okay, the question comes up all the time. Why is it we don't standardize more in the United States? Why is it in the United States? Yeah. It seems like standards are optional, and the answer is really quite simple.
Like the SESME interface.
You have to understand that we live in a global economy. right? Where the supply chain is global. It's not nation by nation. Okay. The United States' role in the global economy is innovation. If you look at where innovation comes from, and by
contradicts standards,
right? Very important here to understand. Innovation is not. I got into this debate with somebody the other day. They were saying that Apple innovates. No, Apple has not innovated since Steve Jobs died. Okay, if you make the M1 chip is not innovation. M2 chip is not innovation. It is a chip with 20% more transistors that runs cooler. That's continuous improvement. Okay, that is not innovation. Innovation is a new idea. It is a new way of doing an old thing. The United States does that. We do the innovation piece. We fail a lot and we get it right sometimes. You know what happens? When we come up with a really good idea that works and that could scale across the globe, other nations are the ones who perfect it. The Japanese perfect it. The Germans perfect it. They're the ones who are developing the standards that then we adopt. This is why IEC is a better standards body than, say, ISA, for example, which is, one is focused in North America and the other one's focused in the EU. The United States is focused on innovation. If you look at manufacturing facilities in the United States and you compare them to manufacturing facilities in Germany, for example, the one thing that stands out in Germany is how standardized everything is. Holy shit. All these production lines are fucking identical, and every operator
they'll over-engineer something that shouldn't even exist.
But you don't, in the United States, we don't do that because we're focused on developing the new product. We're focusing on building a better mousetrap. Everyone is focused on this innovation. There's this innovation mindset, and that is opposed to hyper standardization. What I say that we do wrong is there are standards we could adopt that wouldn't prevent us from being innovative. And so we have to come somewhere in the middle. This would be very hard to do across our entire country, the United States, because
just the way our country is structured,
just the way we operate. I mean, it would just be so, you know what I mean? Like, but go ahead.
So that's where I then join you again, right? So you have now a water utility, and there are several in the Netherlands. And I just have to defend the country that I'm living in at the moment. Where you say you're focused on innovation, the Dutch are some of the most innovative people in Europe, and we are. I say we because I count myself almost as Dutch already. But the Dutch are masters of water management. I mean, a large portion of the country is below sea level. They manage water as an art, right? It is a science here for them. Anyway, but you now have water utility A, and next door to them is water utility B that also has potentially a structure like this, have also gone the hyper standardized route and built their applications like this. If, I don't know, let's say the Dutch government decides, well, let's make all of this public. The government's going to take over all the water utilities, and we're going to make one data ecosystem. Then, if they build a central UNS for all the water systems in the entire Netherlands, or say regions, then you have to say, okay, that UNS has to be non-deterministic because each one of these water utilities have their own standards, and therefore they must be able to define their own namespace in the larger ecosystem. Okay. So then I join you again. Then it's okay. But from a perspective of where an engineer has to manage PLC SCADA applications up to a point, there's a lot of value in being deterministic and doing it this way.
I would also say that determinism and non-determinism within the UNS architecture, they're not mutually exclusive. What I would say is it's possible to be deterministic in functionally and non-deterministic when it comes to data and information as commodity, and they are not mutually exclusive. They can live within the same UNS. And I use this example all the time of just the pure raw, no determinism whatsoever. It's all just grouped by device or hardware that lives in the same unified namespace as the functional DCS namespace, which is fully deterministic. Right. All right, Mark. Okay. Real quick. Zach, any questions, or Josh, any questions on here I got to answer before we call it a day? Anything that you wanted to have us? I don't
really good. I feel like we could have an entire discussion on water.
There was
Water is an underserved freaking industry. Like it's, you know, Lee Taylor's in the comments. Like
real quick right here, Mark, we'll just do this one. Alan Ramsey asked, the AVEVA and Schneider Electric strategic partnership was announced in 2018 in March. Based on your 5-year review, has it been a win-win-win? A win for each company and a win for the potential clients? I think I know the answer there, but.
Definitely win for us and AVEVA. In that we have now, I think, a base of tech with which we are going to shape the future of industrial automation. If you look at what we're doing with universalautomation.org, IEC 61499, the product that we label that under is Automation Expert, EcoStruxure Automation Expert. That and what's happening inside AVEVA with the data hub and the unification that's going to happen in the AVEVA space.
OMI, data hub.
Exactly, all of that stuff. The next 5 years is going to be very interesting. I can't divulge too much, but watch the space.
I would
say, yeah. Win for the customer. It's a bit of a double-edged sword, right? Because while we've already touched on the complexity of if you have to enter Schneider, right, and you have to pick products, depending on who you speak to, you're going to get either product A, product B, product C. Depending on whether you talk to the OSI Pi guys or the Wonderware guys or the Schneider guys in AVEVA, you get differing opinions. So I think there's been a lot of confusion, and yes, we have to own that. And certainly we are the roadmap for the next 5 years is going to be about unifying all of that. And certainly I think a lot of the customers that we support feel that they have got the value out of the system, right? That's the one little anecdote that I can say about Caspar Hersberg. I had the honor of meeting him once, right? And it was at the end of my 4-year projects engineering, just beginning to be a solutions or a sales consultant, just at that inflection point in my career. He was visiting South Africa, and I had to present one of my projects to him. And I did the total engineering thing, right? I went into all the nuts and bolts, and I showed the architecture, and I showed the PLCs and the IO counts and the blah, blah, blah. And it was all very technical. And halfway through, he stopped me, and he said, yeah, I just want to ask a question to everybody in the room. And it wasn't just me. It was my whole management sitting with me, because I'm the little golden boy showing off his project to Caspar Hersberg. He said, what value did you deliver to the customer with this project? And the room was silent. I couldn't give it because I wasn't prepared for that question. He said to me, guys, if you're not delivering measurable value to your customers with every single project that you're doing, you are wasting their money, and worse, you're wasting their time. And that message sort of set the tone for the rest of my career. I'll never forget that moment, because every single thing that we do has to be focused on delivering customer value.
Great.
That's Caspar. And so I believe, yeah, depending on site, you'll always find some customers who can give a story of, well, they weren't happy with this project or they weren't happy with that solution. Yes, we don't do everything perfectly.
I would say,
but we're certainly customer focused.
I was there at one of the very first AVEVA World conferences in 2018 when they, first merged. And I would say it's definitely been a win-win for both companies. And then for the client's perspective, yes, there are things that could be improved, but I think overall a client of AVEVA or Schneider pre-merger is in better hands today than they were post-merger.
Yeah,
they're being more supported and into the future.
And here's my opinion, okay? And this is me, hopefully this is a call to action to Schneider and AVEVA. There's a lot of great solutions there. I really only need AVEVA and Schneider to do two things. Number one, further consolidate the line card so that we have a better understanding of what goes where in the Schneider ecosystem when we're solving problems. Okay, that's number one. And number two, and this is the thing that probably frustrates me the most, I would say, if you are an automation vendor and you do not have a strategic focus on landing your solutions all over the world, okay, the inductive automation approach to expanding your market, landing your solutions all over the world. If me as an engineer can't test your product without talking to some sales guy or getting permission to download it, I'm never using your product. You are literally limiting your market to just through your channels. That's it. And inductive automation didn't go from 1% of the market in 2012 to 33% of the market in 2023 by going through channels. They literally put their software in as many hands as humanly possible. Now, to inductive automation, or to Schneider's defense here, they have a lot more than just one piece of software, right? But this should be their strategy when it comes to software. I cannot go download. I've worked with System Platform since the 10 release. Okay, no, the 9.1 release in 2008 or 9 or whatever it was. There's no reason why I should have to talk to someone to download System Platform and develop some solution and then take that to a client and go, the license is going to cost X, Y, or Z, and we need this much for the engineering. You cannot do that inside the Schneider ecosystem right now. You need to be able to do that. And that's my call to action. You have to call somebody. You got to get somebody inside of Schneider to advocate for you. They're going to go ahead and give you the access that you're looking for.
You got to pay for a development license.
Right. You know what I mean? And I would say right now you should be able to go on Schneider's website, go on AVEVA's website, go on OSI Pi's website, and download the software in any software in a trial mode. Now and be able to build solutions. Their argument is we want to make sure that the solution you build works, so we want to have a touch on it. Okay, you got it.
GeoSCADA and Plan SCADA work like that. You can download it, install it, run it, test
AVEVA
it until you're
AVEVA
blue in the face.
Right? And AVEVA Edge also you can do that with, right?
Okay. Yes, exactly.
Right. Awesome.
So yeah, it's really System Platform, and I agree with you there. I find it extremely frustrating that you need a developer's license to do just even test it.
Well, like that's why I converted to Ignition like in 2012, 2013. It's like, I'm out here selling your software and you're going to charge me. Like I'm a representative kind of for you, you know, like I'm an agnostic consultant, but like if I'm going to sell your solution, you know, don't charge me.
I will say, I do believe it's been a win-win-win, but there's work to be done.
No.
Yes, absolutely.
Hey, Mark, I appreciate you coming on, man. Hey, this, by the way, new record for longest podcast ever. I think our old one was 1 hour, 20 minutes. And so we went 1 hour, 38. Mark, this was a phenomenal conversation. Again, for those of you who are watching, like, subscribe, comment down below. Thank you for sticking us out. And we will see you guys in the next one. Go ahead, Mark.
One last thing. I advertised this stream on my LinkedIn, and I noticed a lot of my colleagues from Schneider said they were going to attend.
Yes.
To all of my Schneider colleagues, if you're not on the 4.0 Solutions Discord, you need to get on there.
Thank you.
There's a wealth of information and discussions happening there that you need to be a part of. If you don't know how to get on there, please contact me.
You can go to iiot.university/Discord. All right. Anyone, thank you, everybody. We will see you guys in